The sum and difference of cubes factoring pattern is very similar to the difference of two squares. Let's learn about it. While we factor using the sum and difference formulas, we should continue to use our greatest common factor, and you need to know how to rewrite monomials as cubes. So if this expression right here is confusing to you, please stop, go back, and review. The sum and difference of cubes factoring patterns are used to factor binomials that have both terms that are cubes. So you remember that a cube is a number that's the result of a number being multiplied by itself 3 times. We have two formulas. We have a sum formula and a difference formula. Now, if you look closely, the formulas are very similar. The only real difference are the signs, positive and negative. In order to remember those, we use an acronym called SOAP. SOAP stands for same, opposite, and always positive. Again, your first sign will be the same, second sign will be opposite, and your last sign is always positive. Okay, to use this method, we have three basic requirements. It must be a binomial, two terms. It must be a sum or a difference, addition or subtraction, and you need to be able to write your expression as the sum of two cubes or the difference of two cubes. Let's try one together. 8u to the third minus v to the third. So I look for a GCF. I don't see one. I'm going to check my requirements. This is a binomial because it has two terms. And it is a difference. Can it be written as two cubes? It most certainly can, 2u cubed and v cubed. So great, let's get started. Now we need to first rewrite both terms as cubes, easy. Then let's choose the correct formula. We have a subtraction sign, so we should use the difference formula. We can now plug our numbers in, 2u first, then v, then 2u squared, then 2u times v, and finally v squared. Last step is to check if anything needs to be simplified. That 2u squared does, that becomes 4u to the second, 2uv, and v squared. And we're all set. Factor 16r to the fourth plus 2rs to the fourth. First, I see my GCF is 2rs, so I'll factor that out. Now I'm going to quickly check my requirements, but in the parentheses only. This is a binomial in a sum, and it can be written as 2r cubed and s cubed. So let's rewrite our expression so that we can factor easily. Next, I'm going to choose the right formula. This is an addition formula, so I'm going to use my first one. Making some space, I'm just going to start dropping my terms in, 2r squared, 2rs, and then s squared. And finally, I just need to simplify any exponents. My 2r squared becomes 4r squared, and s squared, we drop the parentheses, and we're good. Factor x to the 6 minus y to the 6. I don't see a GCF, so I'll check my requirements. This is a binomial, it is a difference, and I think it can be written as two cubes. Yep, x squared cubed and y squared cubed. Okay, the hard part is over. Let's just rewrite everything. So x to the 6 is rewritten as x squared cubed minus y squared cubed. Now I need to choose my formula. I have a subtraction sign, so I'm going to use my difference formula. Now all I need to do is drop my terms in. X squared, then y squared, then x squared squared, then x squared y squared, and then y squared squared. But I noticed something here. Simplify any terms with exponents. Okay, I did that. But look at my first set. X squared minus y squared, dots. So I'm going to make a little space, and then I'm going to factor those two, and I'm finished. Factor x to the 3n minus y to the 3n. I know this looks scary. Let's just follow our steps. I don't have a GCF, so I'll check my requirements. It is a binomial, it is a difference, and it can be written as two cubes. So let's get started. I'm just going to rewrite it, and then I choose my formula. It's difference, so I'm using my second formula, and I just drop my terms in. X to the n, y to the n, x to the n quantity squared, x to the n times y to the n, and then y to the n quantity squared. I'll need to simplify any exponents, and I see a couple, so x n squared will become x to the 2n, yn squared will become y to the 2n. And we're done. Well, look at this factoring tree. It is in full bloom. We finally learned how to use the sum and difference of cubes, which completes our binomial factoring options. We know that we have to rewrite our terms, apply the correct formula, and simplify any terms with exponents. We have to look out for other factoring methods. Now that we're pros, we might have a difference of 2 squares or something else that we have to do afterwards. So that's it for this video, and stay tuned for our next one, which is factoring using the AC method.